Imagine a world where every AI you use, one decision, and the AI world went silent, unless you own it.
I had my entire weekend planned out. I was ready to lock in and use Fable 5, arguably the most capable AI model available, to finally build out a massive project I'd been sitting on. Then, at 5:21 p.m. on a Friday, the plug was pulled. No warning, no appeals process. The model was disabled for everyone. The US government sent Anthropic a letter, and by Friday night, Fable 5 was entirely offline. Sitting there, looking at a blank screen, the reality of the situation set in. Millions of us have built our businesses, our automated workflows, and our creative processes on top of algorithms that live on someone else's servers. We operate entirely by their terms of service. When you rely completely on centralized frontier AI models, your operation is highly exposed. An unexpected policy update, a massive price hike, or a sudden government letter can wipe out your tools overnight. Think about how you treat electricity. Most of the time, you're perfectly happy staying on the main grid. It's cheap, easy, and someone else maintains it. But if a storm hits and the power lines go down, the people who actually stay operational are the ones with a generator sitting in their garage. In the AI space, a local model is that generator. It's an artificial intelligence that runs entirely on your own hardware. You download the file once, and from that moment on, it operates without an internet connection, without API keys, and with zero per-token billing. Because the system is physically isolated on your computer, no corporate entity is monitoring your prompts. The information you feed it physically never leaves your machine, guaranteeing absolute privacy for your data. Deploying a local AI model creates a layer of business resilience that works independently of external internet connections or corporate policy shifts. If you want to build this backup system, the sequence of how you start matters. The first thing you need to install isn't the AI model itself, it's the runtime engine. Programs like LM Studio or Ollama give you the interface to actually load and interact with the files. New users regularly get this backward. They immediately hunt for the smartest, largest AI available, try to boot it up, and instantly crash their computer. This chart illustrates the relationship between parameter size and hardware. For 16GB laptops, the sweet spot is a 12 billion parameter model. Scaling up to massive 70 billion parameter models spikes requirements dramatically, needing serious memory like a dedicated DGX rig. Your available memory dictates your intelligence ceiling. Matching the precise size of the AI to your machine's physical limits is the foundational skill required to run offline operations effectively. Once your engine is running, you select your tools. Alibaba's open-source Qwen 3 family is currently the strongest all-around choice for general tasks. It consistently outperforms older models 4 times its size, making it highly effective for writing code or translating languages. If your hardware is constrained, Google's Gemma model takes up a remarkably small footprint. It produces incredibly clean writing, and the highly optimized versions are so compact they can actually run natively on your smartphone. Then there's Meta's Llama series. Because Meta poured heavy funding into making it accessible, it is the community standard. If you have a highly specific niche use case, there is almost certainly a custom-tuned version of Llama built to solve it. When you rent cloud access, you rely on a single, massive algorithm to do everything. Off-grid AI forces a different approach. You deploy a targeted roster of specialized right-size tools for exact jobs. Taking a file that supposedly requires a massive server and forcing it to run on a consumer laptop requires a highly specific mathematical workaround. In the open-source community, this process is known as quantization. Think of quantization like saving a raw photograph as a high-quality JPEG. You're taking a massive neural network and compressing it down to fit weaker hardware. The file size shrinks significantly, but maintains its reasoning capability. The real leverage comes when you connect this localized AI to an autonomous agent. This agent allows the model to work autonomously, keeping a record of previous tasks and managing its execution loop without ever pinging an external server. Pairing quantization with an agent allows a standard laptop to function as a private, self-contained intelligence node. Mastering local AI creates access to massive B2B markets that are legally inaccessible to cloud-dependent competitors. Take heavily regulated fields like healthcare, finance, or law. They have massive budgets but cannot legally send sensitive client data to a third-party API. If you build an analytical tool where the data physically never leaves the hospital or the law firm, you have a captive market. Or consider operations completely disconnected from the grid. Defense contractors, sensitive financial units, and remote field sites need intelligence software too. Selling an air-gapped agent that operates flawlessly with zero internet connection solves a problem the major tech companies physically cannot address. And after seeing top-tier models get restricted overnight, serious companies are actively evaluating their operational risk. You can sell resilience as a service, a custom, localized fallback layer that instantly kicks in the second their primary cloud provider goes down. Frontier models hosted in the cloud will always be the most intelligent tools on the market. You should absolutely continue to use them. But true, complete business sovereignty comes from owning the generator in your garage. Get your engine running, download a model, and go build something nobody can turn off.
The AI you use today might not be available tomorrow. It is becoming the most valuable resource. Don't wait until intelligence becomes something you have to ask permission for.
We are currently in a period of intense benchmark fatigue. With every new AI release claiming to top the charts, it's becoming increasingly difficult to distinguish genuine progress from marketing hype. But Anthropic's Fable 5 is generating a different kind of noise. Anthropic kept this model behind closed doors for months. Their safety teams were concerned about its autonomous capacity to identify cybersecurity vulnerabilities and provide actionable instructions for creating biological weapons. When the model finally reached the real world, the claims were massive. Stripe reported that Fable 5 navigated a 50 million-line Ruby codebase, compressing 2 months of human engineering work into a matter of days. Today, we are setting benchmarks aside to put Fable 5 through a live stress test across multiple domains. We want to see if it can actually function as an autonomous architect of complex systems. Navigating a 50 million-line codebase independently suggests a significant change in how software is built. If these results hold up, the barrier between a human idea and a finished application is thinner than it has ever been. Our first test involves complex spatial reasoning. We commanded the AI to build a functioning 3D gaming PC visualizer that runs directly in a browser. Fable 5 operates through a chunked reasoning process. It pauses to think, it fetches the data, architects the underlying logic, and renders the visual components. It generated actual 3D polygons for the motherboard, Ryzen CPU, and GPU. This wasn't a library of pre-existing images. The model calculated the geometry in real time. The AI recognized hardware compatibility constraints on its own. It independently sourced and integrated live Amazon pricing links for each component. To test its ability to handle live data, we asked Fable 5 to build a real-time network simulator for Mumbai's local train system. The model ingested live transit data to map out trains moving per hour, highlighting delays and disrupted lines across the city's complex rail grid. It even captured micro-details, like generating a 3D visualization of Churchgate Station that included accurate, functioning platform announcements as trains arrived in the simulation. By coordinating 3D component physics and live municipal data streams, Fable 5 demonstrated a grasp of complex real-world logic that separates it from standard generative models. We escalated the complexity by prompting the AI to build a 3D clone of Dota 2, a game defined by thousands of interacting variables and complex logic loops. Fable 5 successfully architected the core mechanics from scratch, including lane creeps, last hitting for gold, hero abilities, and dynamic health regeneration. It also included a fully functional minimap. This proves the AI is tracking spatial persistence. It manages enemy behavior and world states even when they aren't visible. We then moved to mobile optimization, asking Fable 5 to build a 3D stick cricket game designed for a smartphone interface. The AI coded a physics engine that calculates real-time bat swings and ball collisions based on precise user tap timing. The ability to autonomously generate persistent game loops and reactive physics indicates that Fable 5 can maintain and execute entire interactive environments within its context window. Beyond code execution, we wanted to test Fable 5's capacity for cognitive synthesis, the kind of work typically performed by high-level research analysts. We asked it to generate a full slide deck analyzing the Indian creator economy, following the specific research style and formatting of the well-known Indus Valley Report. This chart shows market segmentation. It identified 4.4 million active Indian creators, noting only 12% currently monetize. It also synthesized future predictions, projecting influencer marketing compounding toward a 5,000 crore valuation by 2027, forecasting infrastructure players rising over individual influencers. The ability to cross-reference data and format complex market insights instantly suggests that junior analyst and entry-level research roles are seeing a major shift in how their work is performed. Across our tests, Fable 5 demonstrated an ability to architect full spatial apps, game physics, and analytical reports from single prompts. When a machine can map millions of lines of code and build functional ecosystems in seconds, we have to ask what the long-term role of the human developer looks like. The period where raw code generation was considered a secure, high-ceiling career is transitioning into something new. This shift provides massive leverage to entrepreneurs and product managers. They can use the AI as a high-speed execution partner, a calculator for complex logic that brings a product to market without traditional engineering bottlenecks. Humans don't compete with calculators, they build with them. The future belongs to those who use Fable 5 to architect their ideas, while those who rely on manual coding will struggle to keep pace.